Hello, everyone, and welcome back to the Moon Builders Workshop series. Thank you so much for joining us today. This workshop has been a long time coming, and I'm extremely excited to welcome Ben and Vansh from API 3. And API 3, you've probably heard of them, but if you haven't, you're going to learn all about them today and how you can build and empower your smart contracts with dAPIs. And specifically, we're going to be talking about payment contracts and more, but it's not just that. It's also DeFi, gaming, NFTs, of course, and more. All these different types of dApps can benefit from reliable price feeds. Now, the Moon Builders Workshop series is a technical series. It's going to be hands-on. There's going to be a chance for you to ask questions, of course, and you can ask them at any time in the chat, and Ben and Vance will pick them up as soon as possible. And make sure that everybody is following along. So I do want to give a quick couple of introductions to Ben and Vansh. So Ben is an ecosystem lead at API 3. He's got a passion for connecting and building sustainable blockchain communities. He's got years of experience, of course, and he has an impressive track record of fostering relationships within the blockchain ecosystem. His expertise ranges from technical concepts to crafting strategies for successful ecosystem growth. Vansh is an accomplished developer relations engineer with a strong technical background and a passion for blockchain technology. Vansh thrives facilitating developer relations, developer interactions, and helping them with their challenges, and of course, strengthening the developer community around the platform. I'm very privileged to be joined by you two today. And thank you so much for joining us for the Moon Builders Workshop. So now we're going to move into a bit of a presentation by Ben. And Ben's going to walk us through how API 3's decentralized Oracle network works, as well as some of the technical architecture and some of the under-the-hood underpinnings of how the decentralized Oracle network works. So with that, let me hand it over to you, Ben.
Awesome. Thank you again, Kevin, for hosting this today. It's always a pleasure coming back to the Moonbeam ecosystem. Yeah, I mean, just before Vansh takes over and runs through the technical workshop and demonstration, I want to give a really quick introduction to API 3 and a little bit more information about how the API 3 first-party Oracle works. So yeah, just to start off with, the kind of core team, the founding team as such, has a legacy of operating an Oracle marketplace from 2018. And the insights they gathered from that operation basically underpinned the white paper, which was created in 2020. If you fast forward to 2023, we are now about 35 to 40 people, globally distributed. We then have kind of flexible contributors on top of that as well. And yeah, we operate as a DAO, which was formed in 2021. And really what we focused on is kind of delivering first-party oracles, of which I'll go into a little bit more. And just kind of recap on the introduction here, my name's Ben. I lead the ecosystem subteam of API 3 DAO. We are very much focused on supporting partner communities and delivering a developer experience that delights and ultimately helps people make use of the oracles in interesting ways. So if you want to get in touch, feel free to kind of join the Discord or get in touch directly with myself. So yeah, I mean, firstly, if you're not familiar with oracles, the kind of crucial starting point here is to understand why a blockchain does need an oracle. If you kind of TLDR this, a smart contract by itself is a programmable piece of law, but without data to be inputted to it, it can't do a great deal of meaningful kind of activities or deliver meaningful services as such. From a technical standpoint, a blockchain cannot consume a continuously updated stream of data from an API. It creates congestion in the network because every time that API is serving data, you would need to also update all of the previous blocks, which would recreate the hash ID and then thus create a kind of huge amount of congestion in the network. So an oracle is very much the kind of middleware or the tooling that provides that smart contract with access to Web 2 data. And of course, it's also then, due to the blockchain being deterministic, a source of truth that is going to be stored on that ledger forever. And just for a little bit of a fun fact, an oracle, of course, is a Greek terminology, which means you speak to both people in Earth and also the gods as well. That's what an oracle used to be and what the oracle kind of naming came from in the industry. What we really kind of set out to do was make it very easy to connect APIs to the blockchain. It's a big focus in the API 3 white paper. It's it's from an insights that we gathered about how difficult it is to currently connect APIs. And what we really need to do here is mobilize the data that is in these Web2 systems, and also enable the people that are building these APIs and forming secure and forming interesting and useful data sources to be included in the API in the Web3 ecosystem. And some stats here that kind of just outline the growth of the API industry at the moment in kind of traditional tech organizations. And if you think about this at a global level, making it very easy to connect those APIs to the blockchain will unlock at scale a lot of this interesting data, and therefore unlock a lot more utility within the Web3 ecosystem. The way we've solved the API connectivity problem is by building a first-party Oracle node. And that basically means it's an Oracle node that is deployed and operated by the API providers themselves. There's no intermediary step to accessing that data. There's not a kind of consensus mechanism that is sitting in the middle of that data supply chain as such. The data, the Oracle node is operated by the API provider. They serve their data on chain as needed, and there's a full end-to-end transparency there. node itself is very easy to deploy. We've built an integration tool, which I'll touch on later, that enables people to do it very easily and independently. It's fully maintenance free. Of course, it's open source, and it basically consists of two key parts. The first is an off-chain Oracle node, which is our node, that is deployed to the API endpoint, effectively sits in the cloud architecture of that API. And then there's an on-chain request to contract, which interacts with an Oracle protocol. The Oracle protocol can be, you can use different types of Oracle protocols depending on your use case. For example, if you're requesting weather data once a day, you may use something like request response protocol. If you need things like price feeds for DeFi, you may use a publish subscribe protocol. It depends on what you're looking to do, but at a high level, you have a requested contract that's integrated into a dApp's smart contracts, and then you have the off-node air node, which is waiting for requests from the on-chain protocol, relies on RPCs to do so. And yeah, as a high level, that's kind of what it is. And then just kind of outlining here, what the differences is, or what API 3 brings to the Oracle landscape, perhaps. You can see on the left-hand side an Oracle architecture that's probably more familiar to most people. There's the data sources are perhaps not known. There's no prerequisite for a data provider to identify themselves, but that data provider will serve data into an Oracle node, which is effectively kind of a middle step in that architecture to actually reaching the smart contracts itself. On the right-hand side, you can see the Oracle node is deployed directly to the API provider's endpoints. That then is served directly on chain. If you're using multiple data points for perhaps DeFi protocols, that is then aggregated native chain, so it has native chain aggregation. So if you're deployed onto Moonbeam and you're using 5 different sources of data for DeFi, you can then have that aggregation perform in a similar way, but it's a lot more transparent, and you can understand crucially which data sources that you are using, and you can understand if that data source is perhaps someone that you trust, and how many sets of data you'd like to aggregate for your use case. Additionally, the API 3 is governed by DAO. We think that for smart contract infrastructure, and if we're building a programmatic on-chain set of services, DAO governance is an appropriate way to provide that transparency and accountability, but also for people to participate. So we see that including API providers in this Web3 ecosystem, it's going to enable them to think about how they can innovate or serve better data services to smart contracts. It also allows them to understand how many dApps are consuming their data sources, and thus be incentivized to increase or look to increase that number of dApps. So long term, it makes sense to include this large kind of economy of people who are dedicated to providing APIs in what is in the Web3 ecosystem as a crucial kind of foundation there. And API 3 sees the DAO as the way to decentrally govern that and then enable the mobilization of all of that data. And yeah, kind of just building on that, to do that at scale, of course, deploying a node needs to be very easy. And alongside API 3, we have a kind of partner sister entity called Chain API. And at the moment, this is an Oracle integration tool. So if you are building on Moonbeam at the moment, you can go in to Chain API. You can find an API provider's documentation that you require to deploy an Air node to. You will need their permission to do so. But Chain API can talk yourself or the API provider through a process to deploy an Air node to that API endpoint. It shouldn't take longer than 30 minutes, assuming you're kind of familiar with the API. And yeah, this is completely free to use. It allows you to do a lot more within that process. So if you have like pre and post processing, for example, within your APIs, you can start to add that within the Chain API tooling. You can do things like parameters and kind of authentication methods, for example. So it not only allows you to integrate, but allows you to manage. And if you want to cancel or kind of upgrade or switch your services, Chain API is the place to do so. And I'm just linking some guides here, which can talk you through how to do this in a very kind of simple, easy way to follow. And yeah, I guess kind of switching on a little bit here. So Vansh is going to talk you through a demonstration for a payments contract. So, this is a little bit of information about API 3's data feeds. At a high level, going back to the architecture I mentioned earlier, within price feeds, you have, ideally a set of data that is maintained on chain. If you're a lending protocol or a perpetuals futures, perpetuals DEX, for example, you need to have access to the most, well, not the most recent, but the most relevant, or ideally, the most recent, depending on what deviation threshold you require, data for your smart contract to execute transactions against. The way that we do this at the moment is, well, there are two currently dominant architectures at the moment. The first is what's known as a push oracle. That basically means, according to a set of predetermined kind of frameworks or predetermined specifications, an oracle will update. A pull oracle enables people to request data when they need to kind of execute perhaps a trade or perhaps a liquidation, for example. And yeah, diving into that a little bit further, what we're going to demonstrate here today is a push oracle architecture. And within that, we have different variables. So the feed we will demonstrate today is a self-funded dAPI. That is a deviation threshold of 1%. We will offer deviation thresholds down to 0.25%, I believe. So every time, let's say, a certain asset goes up by 1%, that will trigger off 4 price updates. If you have a deviation threshold of 1% and it goes up 1%, it'll only trigger 1 update. Heartbeat, likewise, you may want that price to be updated every hour. Perhaps you just want to ensure that the latest market data for X equity is available, and you can also pre-build in that heartbeat function is needed. What it boils down to, though, is that all of this is associated to Oracle transactions and costs associated with Oracle transactions. So if you have a heartbeat of every 30 minutes and a 0.25% deviation threshold, you're going to start to occur certain overheads with operating that Oracle, particularly when gas fees are high. And there's I think the kind of interesting thing about API 3 is that you will be able to understand, or we'll be able to choose the amount of sources that you require within your Oracle architecture, Oracle data feed package, according to the kind of use case that you have. What we will be demonstrating today is a self-funded API. This is effectively a permissionless Oracle service. It's available through the API 3 market, and it enables people to provide the gas collateral required to operate that Oracle. There's an estimation tool within the API 3 market that allows you to say, let's say we need this feed for 2 weeks. Perhaps you're in the early phases of your development cycle. You just want to test your dApp in a kind of mild production environment. And this would be a perfect solution for you to do that in a flexible way, no like long-term commitments associated, but also you're still accessing here a data feed that is aggregated. It just has off-chain aggregation, so it's aggregated before being served to the blockchain. And I guess crucial thing here is that the process of integrating a self-funded dAPI is exactly the same as if you were utilizing a managed, a decentralized dAPI. And if you have already added a dAPI to your contracts, you do not need to do any further technical lifting or changes to the code to switch between those two services. You simply go to the API 3 market. You'll have an individual proxy address. A proxy address will enable you to kind of redirect which data feeds you're consuming within that contract. And the same goes for kind of future API 3 services such as Oracle Extractable Value. And that's everything from me. Thanks for kind of that quick kind of 10-minute overview. I hope that people found it useful. If there's any questions that you have, feel free to get in touch. But I'm going to hand this back over to Kevin and then Vansh, who's going to kind of demonstrate to you how to build a kind of payments contract using a dAPI, and then how to integrate and activate the API 3 price feed solution. So thank you very much.
Fantastic, Ben. Thank you so much.
All right, so I'll just share my screen. Yeah, so I'm Vansh. I also work under the ecosystems team with Ben at the API 3 DAO. So today we are taking a look at a small project. It's basically like a payments contract. So what we're going to do is just to demonstrate how self-funded APIs work, we're going to build a simple dApp to accept any ERC20 token payment, and then mint an NFT receipt to the user with the USD value. So if someone makes, let's say, if someone wants to make a payment of 2 dApp DETH to the payments contract, after making the payment, it will mint an NFT as a receipt to the user of the USD value of that payment that the user made. So if it's 1 dApp DETH, it's going to be $1,800, the value of Ethereum at that time. And that's how we're going to use dAPIs for that. So this is the project. If someone actually wants to use this, just drop the link quickly in the chat. And I've also made a quick front end if someone wants to use it. So you can just go in, connect your wallet on Moonbase Alpha testnet, select the token that you want to pay in, enter the amount, and then it will mint an NFT to your account. And then you can check the NFT by the token ID. And it will display how much you paid to the contract at that time. So to do that, you can just go over here, and I've made a separate branch for Moonbeam for a specific Moonbeam deployment that you can just go through. So you clone this repository, you install all the packages, you copy the credentials, and you put in your mnemonic, and then you compile and deploy the contracts, and then you can use these scripts to interact with the contracts. So I think now we can start building the contract. So here I'm going to use Remix for this because it's really easy to compile and deploy contracts with this. By the way, anyway, is this visible to everyone? Or should I zoom in more?
It looks fine to me. You can maybe go one more. Yeah, okay. Perfect. That's amazing news.
Awesome. So it's a basic smart contract. Like I've just copied the imports directly because it's going to take some time to write them down. So we are importing ERC 721, the basic Open Zeppelin NFT implementation, then the enable to access the only owner modifier, the iProxy interface to interact with the dAPI. So to read a specific dAPI, we can just call the .read function from the proxy interface. So each dAPI on the API 3 market is represented by like a proxy contract. So what you can do is if you want to, let's say, access the ETH USD proxy, you can just go in. You can select the network that you want to use it on. So here we have selected Moonbase Alpha testnet. So you can see my wallet is already connected. And here I can just fund the gas of a specific dAPI and start using it. So in this case, as you can see, the gas is already funded, and here's a approximate value for how long this dAPI will operate on the remaining gas. So if someone funds it, anyone can just copy the proxy contract address and can start using it. You have to make sure the self-funded dAPI doesn't run out of gas. So yeah, we'll discuss about this later. But to start off with the contract, we can initialize our counters. So using counters for counter.
And Vansh, if you want to keep it going, you just have to send funds to that contract.
Yeah, so it's basically you fund the dAPI sponsor wallet that actually updates the dAPI on chain. So yeah. If you want to actually just keep it going, you can,
Okay, cool.
Let's say if you want to fund it for 12 months, you can just send dev to this wallet and it will keep on going.
Oh, cool.
So yeah, we will initialize the counters. Let's call it token ID counter. Yeah. Now we can move forward and so initialize the ERC20 contracts. And now we can set all the mappings that our contract requires. So the first mapping that we want to set is a token proxy mapping. So it's an address to address, of course. It's going to be a public mapping. Token proxy mapping, let's call it that. And yeah, if you guys have any doubts between, you can just ask me. The next mapping would be a token ID to price. So the first mapping represents the token to a proxy, basically token to that points to a specific dAPI. So if I'm gonna add like wrapped ETH, like if someone wants to make wrapped ETH, a payment in wrapped ETH to this contract, so that wrapped ETH contract the token contract would read from the wrap ETH USD dAPI from the API3 market. The next mapping would be token ID to price. This will be used to check our receipt. So public, let's call it token ID to price. And we'll just make a simple array for storing our addresses for allowed tokens. And yeah, now we can move forward and initialize the constructor. It's going to be an ERC-721 contract. Let's call it payments receipt. And the symbol can be PRT, payments receipt token. And now we can move forward and code all our functions that are required. So the first function will be set dAPI proxy. So of course, it's going to take in the address of the token and then the address of the proxy contract. It's going to be a public only owner function, of course. So we want this function to be called only by the owner of the contract because it's a critical function. So with this function, we'll just basically update this token proxy mapping thing. So we just add in token proxy mapping, takes in the token and update it with the proxy. And yeah, the next function would be to add allowed tokens. That also takes in the token address. It is also going to be a public only owner function. So we are basically gonna push this in the allowed tokens array. Now we can also use we can also use a mapping for this stuff, but I'll explain you later why I'm using an array for adding allowed tokens. So the next function would be token is allowed to check if this particular token is allowed on the platform or not. Takes in the address of the token. It's going to be a public view function that just returns a simple Boolean value. We're going to run a for loop here. So for UN 256, I equals 0, I less than allowed tokens dot length, then increment I. Then we can add our logic here. So if allowed tokens I is equal to this particular token, then return true. Otherwise, we just want to return false. That means this particular token that the user wants to make a payment in isn't allowed on the platform. We can move on to the next function. Now, this is the main function where we actually call the dAPI. So, like read from the dAPI. So we call it get token price. That basically takes in the address of the token. Again, it's going to be a public view function that returns a uint 256. Let's call it token price uint 256. Yeah. So let's get the proxy address from the mapping. So here we set the token proxy mapping that takes in our token and returns a proxy address for that particular token. So for the dAPI to work, as you can see, if you want to read from the dAPI, it returns a value and a timestamp, the latest value of that particular dAPI and the last timestamp when it was updated. So we will quickly go over and make an int224 value and then a uint 256 timestamp, and just simply gonna call the dAPI value timestamp equals iProxy. That takes in the address of the proxy contract and calls the read function from the it's that simple. So it's basically a read function that gets called, and yeah, it just basically returns the value and the timestamp. But the value that is being returned to us is an int 224. Now to convert it, we first convert it to an unsigned int 224, uint 224 token price uint 224 equals 224 value. The reason why I'm doing this in so many lines is to explain how we are converting the value, because it's kind of important. Now token price uint 256 can just be automatically converted to a uint 256. So token price uint 224. And yeah, there we have it. So we can just call this function to get the token price of the supply token. So the next function would be to make the receipt. So this function would just basically take in the token ID and the price, basically the price at which the price of the assets that the user made the payment in, so that it can make the receipt for that. So it's an internal function. Internal returns a uint 256. So token ID to price mapping, we update, we send in a token ID, and of course we return the price. That's it. Now the main function where the user makes a payment. So function payment. Now this is the most important function in the contract that the user would actually call. So the address, the token, uint 256 of the token amount. It's a public function that returns uint 256. Now we're going to set some require statements to see if, just to check if the token amount isn't 0. So the token amount should be greater than 0. Otherwise the transaction can just revert. cannot be 0. Then require, gonna check if the token is allowed. So if it's not allowed, then yeah, also throw an error. Token not allowed. And now we can actually just run the main code. So if the token is allowed, can now run our logic. So we first get in the token ID. So UN.
You might have a typo on the require statement. I'm not sure if allowed.
Oh yeah. Yeah, token is allowed. Yeah. Oh, thanks. So yeah, uint token ID, and this is where we actually use the counter and get the token ID counter. So token ID counter dot current function, it basically returns the current counter of the token ID. And then we increment the token IDs, token ID counter. So token ID counter dot increment, and the next step for us would be to get the decimals of the token in which we're making the payment in. So like right now it's easy for us because here we are using two tokens, wrapped glamour and wrapped ETH. So these are not actual token contract addresses. These are just like the OpenZeppelin implementation that I'm just going to use. So what it does is it basically like mints 1,000 tokens to the address of the deployer of this contract, and we just call it wrapped glamour. It's not actually wrapped glamour. But if you want to use this contract in production, then you can just swap out the token contract addresses to the actual addresses. So like these, these token addresses would be having like an 18 decimals, but let's say if you want to use USDC, that's usually in 6 decimals if I'm not wrong. So to avoid that, we'll just call the ERC20 method to get the decimals of that token. So decimals, this would return us the decimals of that token. UN 256 token price UN 256, and here we get call the get token price function. Pass in the token. Now we need to get the USD value of the payment that the payment that the user made. So to do that, we make a USD value variable, and we basically token price UNT 256, and we multiply it with the token amount that the user sent in. So token amount, and then we divide this with 10 raised to power the decimals to convert the value from ether to way, from way to ether, or ether to way. And yeah, that's basically how we do it. So after everything is done, now we can actually call the main transfer from function that actually makes the payment. So ERC20 that takes in the token dot transfer from, wait, is this? Yeah, transfer from message dot sender to address of this contract, and just transfer the token amount. And yeah, this would basically just make this payment to the contract. And after the contract made the payment, now we can just, after we have made the payment to the contract, now we can just quickly mint the NFT with the token ID to the user, and also get the receipt from make receipt function, returns token ID and the USD value. It basically mints a receipt with the token ID and the USD value. Now you know why we call the why we made the make receipt function. And yeah, just return the receipt here. It's fine. Then now we're just going to make some functions like this view function through which the person who actually made the payment can check their NFT and see how much payment they made in USD during that time. So this will be, let's call it check receipt, takes in UN 256, takes in the token ID. Basically, I think calls the mapping, returns UN 256, and we return the token ID to price mapping. Just takes in the token ID. Yeah. Why is it showing an error over here? Oh, I forgot semicolon. Okay. Now I need to make some functions for the deployer of the contract to see how much funds are there in the contract. So like you can just go on like a block explorer and see how much ERC20 tokens are there, but to actually get the USD value of all the funds in the contract, we can just make a method called get contract balance. So public view, anyone can call it, returns UN 256. So let's make UN 256 balance equals 0. We can just run a for loop for UN 256 I equals 0, I less than allowed tokens dot length, and then increment I. Now we can add our logic. So UN 256, let's call it token balance equals ERC20. So now we're going to loop through all the allowed tokens and see the balance of this contract, like how many allowed tokens does this contract hold. So allowed tokens I balance of method from the ERC. It's going to be upside dot balance of address this. Yeah. And the next will be, the next variable will just get the USD value, like to calculate the USD value of this token balance. So get token price, I'm going to call this method again to allowed tokens dot I. It's gonna balance off again. Oh wait, no, we can just, oh no, we're gonna just multiply this. So get token price, allowed tokens into token balance, and then we can divide this entire value to get the decimals out. So ERC20 again, allowed tokens I dot get decimals. So dot decimals, this would return us the decimals of this contract. And now we can just update the balance. And after it is done, USD value of the token. Yeah. And then we can at the end just return the final balance to the user of how much this contract holds in USD value. And the final method would be something similar. It's going to be owner withdraw funds. So only the owner should be able to withdraw funds from the smart contract. Only owner. Again, we are going to make a for loop, and this is going to be a final function. So we'll now get to the fun part of deploying the contract and see how it works. So event I equals 0. I is less than allowed tokens dot length, then I plus plus we can just note this. Yeah. So yeah, now we can call the ERC20 again, allowed tokens, loop through all the allowed tokens. And this is the reason why I used an array for the allowed tokens, because I don't want the owner to manually put in the address of each and every token and then click on withdraw, because we can just loop through an array, and with just one click, it would withdraw all the tokens from the contract to the wallet of the person who's going to call this function, that is the owner of the contract. So yeah, so transfer message.sender in this C20. Or you can also use owner with the only owner modifier, but I'm just going to keep this like this for now. Allow tokens I balance of address this, and yeah, and this is like just going to loop through all the tokens and would withdraw the funds for us. And yeah, using counters for counter.counters. It's counters.counter. Okay. So one more issue. Tokens push. Oh, it's a typo. All right. So here we can just now deploy this contract and see how it works. As you can see, before deploying this contract, we would first have to deploy these token contracts. So to do this, make sure you're on Moonbeam Alpha Testnet, and I have some dev tokens here with me. So I'll just select injected provider MetaMask. Compiles. Let's first deploy wrap glamour, so we can just compile this token and deploy. Yeah, so in the meantime, we can just quickly compile this contract too. Wait for this deployment. So awesome, we've deployed this contract. Now we'll deploy wrapdeets too. Meantime, we can now just go there, compile our main contract. Yeah, so we have deployed both of our token contracts now. This is wrapped GLMR token, and then contract creator, contract creation. Yeah, and then this is the wrapdeet contract. So here we have two token contracts now, and now we can just deploy the main payments contract. Let's wait for this to finish. Yeah, so as you can see, we have deployed all the three contracts. Now, before moving forward, I would just go onto my wallet and quickly add these assets, import these tokens. So it should automatically detect the token symbol and the decimals. And add custom token, import. Same, I'm going to do this with wrapdeet too. And there we have it. So we have both of our assets in a wallet. 1,000 tokens. Now we need to copy the address of the payment contract and approve the spending limits, of course. So for that, I can just go to this Ether2 way converter. It's an online tool that I usually use. So yeah, the spender is of course going to be the payments contract. C0, yep. And the amount. So let's say if the spender, I wanted to, let's just do it. Oh, yeah. 1,000. Let's just give it the full spending limit, although this is not recommended in a production use case, but I'll just use it. I'm going to do the same thing with wrapped each. Set the spender and yeah, let's just wait for this transaction to get done first. And yeah, we can approve wrap dates now. Approve. So after we've approved the token contracts, the next step for us is to add these allowed tokens in the contract. So let's just wait for this transaction to go through. And there we have it. We have now set the spending limit for both of the tokens. And now we can just go forward and add these allowed tokens. So let's add them. We could have just made it call data addresses to send in multiple token addresses too. Just noticed. That's fine.
So, oh yeah, I do have a quick question, which is sort of tangential. If we have time, or I can kind of hold them towards the end.
No, it's fine. You can just go on. I'm just deploying this just adding the tokens.
Yeah, let me save them for later so that I'm not.
All right, that's fine.
So they're not.
So the next, So the next step for us would be to set the dAPI proxy that points to the dAPIs. So as you can see, we added wrapped glamour and wrapped ETH here. We can now point these token contract addresses to the proxy addresses through the API 3 market. So now we can see how we can actually interact with the API 3 market. So here, as you can see, we have all these dAPIs available, ready to use, and these are self-funded. So first, I want to set a proxy for the GLMR token. As you can see, here we have the dAPI for this token. Let's select Moonbase Alpha Testnet. So here you can see there's a deviation threshold of 1% and the last updated value of this data feed. So it last updated 26 minutes ago. And here you can see it's been funded for 65 months and 29 days. That's a really generous funding, but it's a testnet. So just to demonstrate on how we can fund a dAPI, I'll just quickly do it. So I click on the fund gas button, and here's a gas estimator tool that I can use. So let's say if I want to fund this dAPI for 10 months, it would display the amount of dev tokens that are used on this testnet to see how much tokens that I have to supply to fund this dAPI. So I can just click on send dev and click on confirm.
This is really, really cool to see.
So as soon as the transaction gets confirmed, So it's a proxy contract, so it's self-funded. If anyone just comes in and funds this dAPI, it's going to go on for that period, and anyone can read from it. So it's a read function that the dApps call to read the price feed. All right, it's done. And here the proxy contract address is already there. So in some cases, for some dAPIs, the proxy contract is not deployed. So the user can just go in and click on deploy and deploy this contract. Or you can also read this guide on how to actually read a self-funded dAPI proxy. And this is a really cool guide that you can refer to if you just want to read the dAPI and integrate it in your smart contract. So as you can see, again, a similar step that we have done. Yeah, let's just go back and copy this token contract address, and then copy the proxy contract address, point it towards it. Now, while the transaction is going to confirm, we can just go back and search for ETHUSD dAPI. Again, Moonbase Alpha testnet. So as you can see, it also last updated 32 minutes ago, and the deviation threshold is also 1%. So this dAPI is already funded. So yeah, I think you can just start using it. So I can just click and copy proxy contract. Okay, so it's done. Yeah. So this is the proxy contract address for the ETHUSD feed. You can gonna point it towards the wrapped token and confirm. This was the final step. Now we can now just make a payment to this contract and mint an NFT. Just wait for this transaction to confirm, and it's done. Now this is the main payment. This is the main payment function that we're going to call. So let's say if we want to make a payment in Wrap Glamour, you can just copy the token contract address. And how much do I want to pay? So let's say if I want to pay in 50 Glamour tokens. So you can just copy the way thing and click on transact. And as you can see, I've already approved the spending limit. So I can confirm this transaction. Let's wait for it to confirm. And there we have it. We can view this transaction on chain on the block explorer. And as you can see, it minted the token ID. So it minted us a token ID that we can actually, the payment receipt token that we defined in the contract. And now we can refer to it. So to actually check the receipt, we pass in the token ID, we call it, and there we have it. So this is the USD value. Yeah. So yeah, 50 Glamour tokens are worth 13 USD, and at the time when I made the payment. So that's how you can use the payments contract and can make payments. So you can do the similar thing with Wrapdeeds too. So as you can see, we just made the payment, so it got subtracted from a balance. And yeah, there are other functions too. So if you want to, if the owner wants to withdraw all the tokens to his address, and if you just want to get the total contract balance, you can do that too. And if you want to actually just run this on your own system and try it out, you can go over here, clone this repository, and I've made scripts for each and every function, so you can just easily call them. And if you want to try it out with the front end, you can do that too. So you can just point the front end to the to your contract addresses, and you'll have it. So this is the simple front end that I've been using with a different deployment, and you can use that. Yep.
This is so sick. One of the best demos we've ever had. So thank you so much. And just a couple quick follow-up questions. So if I think you covered this, but if a self-funded dAPI is already funded, can anybody just step in and use that?
Yeah. So if it is already funded, you can see a gas estimation right on the dAPI page for each and every dAPI. And yeah, if it's already funded, then one can just come in and start using it.
Awesome. And it was cool to see the ability to add and see the estimates and for how long it can keep running for. And can any API be called using an Air node?
Yeah. So let's say if a person who wants to use Air node instead of dAPIs, and if they want to integrate their own APIs, so you can use Chain API to actually integrate your REST API and make a configuration file for the Air node and then deploy it on your cloud provider. So instead of actually sourcing the data from a data provider, you can use your own APIs and can serve that data on chain. So for that, I've made a simple guide. I think I shared the link above, right?
Was it chainapi.com?
Yeah, it's chainapi.com, and
Cool.
there's a
the
better
guide,
programming. Yeah, the better programming guide. I'm going to share it again. If someone wants to refer to that. Yep.
And did we just want to give a quick reminder about the QRNG?
I'll try and. I don't know if my microphone is having issues, but I don't know if it's managed, but if you can do it.
That's okay. Yeah, we just have a couple minutes left.
Yeah, so for QRNG, yeah, if someone wants to actually, I saw a question that someone wants to use QRNG. So if you want to use that, we also have guide for it. So you can head over to docs.api3.com.org and wait, just share the guide. So you can see this getting started with QRNG section, and you can go over the stuff to see how you can access quantum random numbers inside a smart contract. So, and it's as simple as calling an Air node. So yeah, and we have some other guides like building a roulette with QRNG, or minting dynamic NFTs with QRNG, or building a lottery with QRNG. So yeah, you can do all of these things with QRNG.
This is so cool. Well, we're just about out of time. And I want to thank you so much, Ben and Vansh. You guys were amazing. And we had an active comment section here. So we thank you so much for folks who joined here. We also had Twitter. We were live streaming this as well on Twitter and picked up quite a lot of views there. So exciting to see. This is also going to be posted, of course, on YouTube. So people can watch this. They can go back and step through the demo if they'd like. If you like to do it parallel. And don't forget, there's also that UI. So you can check out the UI. You can build it yourself. And this is phenomenal. I mean, this is really exciting, guys.
Glad you liked it.
Thank you so much for joining us this morning. And I hope to see you again on a future Moonbuilders workshop.
Always.